video. And as you can see, today I'm going to be doing more Codewars challenges. I think you could say that's similar to LeetCode, though LeetCode is focused more on interview prep, and I think you could say Codewars is just in general small practice problems to just get better. They are not specifically something that you would see in interviews. So I've already selected the first problem here, and we are supposed to complete a function that accepts two integer arrays of equal length. You can see here array A and array B, and then compares the value each member in one array to the corresponding member in the other. So for example, down here we have 1, 2, 3, and then 4, 5, 6, so we compare 1 to 4, 2 to 5, and so on. And then we square the absolute value difference between those values. So 4 minus 1, or the difference between them, is 3. And you square that, and that's 9. And then we return the average of those squared numbers over all the pairs. So let's just take this, and I will develop this in my own IDE, but let's also copy paste the examples. Okay. Now we need to go through each array. I think there's a nice zip function for that or something like this. So I think we do for entry A, entry B in zip array A, array B, and let's just print A is entry A and B is entry B. Let's just try this. Take this example array. This will be our A and B. And then we do solution of AB 1, 4, 2, 5, and 3, 6. So this seems good. Zip seems to be working. So now we need to take the absolute difference. So let's entry A minus entry B, and I think that there's just an abs function. Don't know if I need to import this from the math package. Doesn't seem like I need to. Okay. And then we want to build a list with that. I think we can do this with a list comprehension. So return the mean. Okay, so Google says we need to import mean before we can use it. Okay, and then we will do abs of entry A minus entry B for entry A, entry B in zip array A, array B. And I think we can then just do it in one line. Let's try this. Oh, I forgot the squaring, right? So square the absolute value. That seems to be correct. So now we take these two, and then it should give us 16.5. That's correct. And does it work for negative values as well? Yep. So we take this and try it. Oh, we need to from statistics import me. Can I do this? Am I allowed to do this? Seems like I can. Okay. Attempt. Passed all the tests. So this is correct. Submit. You have ranked up. Powerful you are. Your new overall rank is 5Q. I think before we were 6 and you rank up. Alright, so let's try this, which is supposedly a bit more difficult. In this kata, you have to create all permutations of an input string and remove duplicates if present. This means you have to shuffle all letters from the input in all possible orders. The order of the permutations doesn't matter. As always, the examples are the best way to understand this. So if we get the string with just A, then we return a list with just A. But if we get the string AB, then we return AB, but also the shuffled version, BA. And when we get AABB, then you can start to get an idea of why this is difficult, because then we return AABB, but also ABAB, ABBA, BAAB, BABA, and BBAA. Now, I think there is in the ETA tools package, or maybe there's a, no, maybe there's a specific combinatorics package, and that would probably do exactly this, but I think the main reason here why this is a task is to do it by hand, so I will try this. Let's create a new permutations part. So my first idea here is to do something recursive, though I think if you can do it recursive you can probably also do it differently, but this kind of makes the most sense to me right now. We'll see. Okay, so first we need to get all of the combinations, so I want to rename this. Okay, so we need to take all of the letters in the input string. For letter in input string. Found permutations. We need to save these somewhere, and then for each letter we will. Okay, let's try it recursively first. This might be a horrible idea. you always run the risk if you do it recursively that you run out of memory real quick and stuff if you just spawn thousands of sub calls. But my idea would be if length of the input string is smaller or equal to 1, then we just return a list with the input string in it. Like up there, if we get an A, we just return a list with the string A. But if it's bigger, then we need to find multiple permutations, and then we will add into the found permutations. We will take out the one letter, so remaining letters will be input list of an input string, but remove the letter once though. We have to see if we remove A, if that removes all the A's in it. So I guess we just do, instead we go over it like this, with indices. Remove first occurrence of value. Okay, so it only removes one. Could have kept it like this. So we take out the one letter that we're using and we use all the rest. And then we call permutations on these remaining letters. Oops, permutations. Oops. Scroll down a bit. And then we will make a string out of adding so we will go through all the subpermutations, and these will be strings, and let's try adding two strings together, see if it works the way I hope it works. Okay, so we can just, but does it also work if it's just one letter? Yes. Okay, so we can just add the letter onto the subpermutation. These will be the new permutations for each letter. So we will add them to our found permutations, and at the end we return our found permutations. Let's see what this does. Permutations of A gives us A. That's the special case that we build up here. But if we type in A B. The kernel died. Okay. That's unfortunate. Let's take this. Input string will be AB. Restart the kernel. Run all. Okay. Print remaining letters. None. Okay. Oh, this doesn't return a list, does it? Yeah. Okay. Okay, let's do it like this. We need to first create a list and then remove a letter. Because this doesn't return it, it just modifies the list in place. So if we do the same up here, remaining letters, and now we try permutations of AB. Oh god, this already takes way too long. So let's see. Print letter, it will be letter, and then this will be remaining letters. Oops. Like this. So if we have A, the remaining letter is B, and then we do string of the remaining letters, and that is still a list. Oh, okay. We don't need to make a string out of it, we need to say join either this way or the other way around. Maybe the other way around. Oh, no, this is the problem. This is the problem. Okay. So now this is a string. We can also do a colon here. Okay, I always forget that's not how you do it in Python apparently. Join the remaining letters together again. Unmatched parentheses. Do we dare try this again? Permutations of AB. AB and BA. Okay. And now AABB. Yeah, now we get a lot. And now we get duplicates, as you can see, so we get 2 times the AABB. So to remove duplicates, we do my god. So the only hack that I know basically is there a unique see. No. So yeah, the only hack that I know basically is to make it a set and then a list again, because sets can have duplicate values. I'm not saying this is pretty, but it works, you know. Let's see. ABBA, AABB. Wait, 6 different. Okay, AABB is here, ABAB is here, ABBA is in the front, BAB is here, BABA is here, and BBAA is also here. That seems to be promising. I'm not saying it's pretty, and it might also run into problems if they insert longer strings, but let's try. Test. Passed. I mean, these are probably the tests that we already tried. And attempt. Passed. Yay! Okay, let's do another short one to round this off. This says no story, no theory. The examples below show you how to write the function accu. So if you put in A, B, C, D, it wants a capital A, dash, and then because it's the second letter, a capital B and another B, and then a dash, and then 3 C's because it's the third letter, and then 4 D's because it's the fourth letter. Again, let's rename the input string. Don't really like it if it's just S. Okay, so we need to have a counter, and then I guess we don't necessarily need a counter. I think we could do for I and letter in enumerate input string. Print I and letter, just to show you what that looks like. Vacuum A, B, C, D. So 0, A, 1, B, 2, C. Now you might think this is one off because we want 1A, but we want a capital A. So complete string will be empty at the start, and then we a lower. Cool. Okay. So we will add letter upper plus I times letter lower. And that might be it. So, because if we do A times 3, yep, then it gives us 3 times the A. And that's what I do with the I here. So let's see, A, B, C, D. Oh, I didn't execute this. Let's run this again. And run. Cool. I mean, returning the result would make sense, I suppose. Right. I forgot the dashes. Okay. That's fine. That's fine. Let's do them before we add the rest. So if I is bigger than 0, add a dash. Alright, that looks good. See if it also works for different capitals. Beautiful. remove the print statement. And let's try this. Test passed, and real test passed 120 out of 120. Alright, like I said, I'll wrap this video up with this third challenge. I hope you enjoyed this quick challenge coding video. Thank you so much for watching, and I'll see you in the next one. Bye!